to the first physics lesson and your first GCSE topic. This topic is all about particles. So I'm going to share my screen in a minute and we can begin our work. Before we start our work, can you make sure you've got a pen, a pencil and a calculator for today's lesson, and that you've opened the worksheet that is attached to this lesson. If you want to print the worksheet off instead and write on it, that's fine, but you'll need to submit a photo or upload some evidence at the end of the lesson. Okay, I'll share my screen and we'll get started. So, please may you write in your books the title of today's lesson, which is Density. Title and underline, and we'll start your first ever physics GCSE lesson. Okay. First of all, let's start thinking about the particles in solids, liquids, and gases. This is something you've learned about before, so you should know what the arrangement of the particles looks like, and you should know something about how they move. Now we're going to do our first job on the worksheet. So you'll see the worksheet has a page on it, just like this. There you go. You can see it's got a blank square for solid, liquid, and gas, and some space for writing. If you've got a printed off sheet, then you can be writing and drawing on this. If you're working on the electronic worksheet, you can use the drawing tool to insert pictures in these boxes. The first thing I want us to do is to draw a picture of what the particles look like in a solid, a liquid, and a gas. Let's see what they should look like. Add these to your worksheet. When you draw the particles in a solid, they should be arranged in a regular pattern, like rows. The particles should be touching each other or very close. The particles should all be the same size. When we draw the particles in a liquid, we should still draw them touching each other. But the particles are now in a random arrangement. The particles are all the same size. Finally, when we draw the particles in a gas, we draw them far apart. They are in a random pattern. The particles are still all the same size. If you want to pause the video now to finish your drawing, you can do so and then press play when you're ready. The next thing we need to add is some information about the particles in solids, liquids, and gases. Your worksheet says draw the particles in their states and note their movement and arrangements. So how are they moving and how can we describe their arrangements? Let's look on the next slide. In a solid, because the particles are in neat rows or lines, we say the particles are in a regular arrangement. For GCSE, you can't write that they are in neat rows. We need to start using the proper science words, and that word is that they are in a regular arrangement. The particles are all touching, and the forces between the particles are very strong. It is very hard to pull the particles in a solid apart from their neighbors. The particles vibrate in position. Although the particles cannot move around freely, they wobble slightly in all directions, vibrating, a bit like someone fidgeting in a seat. Add these notes to your worksheet now about solids. The particles have a regular arrangement and the particles vibrate in position. This can go in the box beside the picture you've drawn about solids. If you want to pause the video to do that job, you can do that now. In a liquid, the particles are in a random arrangement. You might have said at key stage 3 that they are jumbled up or not neat. For GCSE, again, we need to use the correct words, that they are in a random arrangement. The particles are touching, and the forces between the particles are medium strength. Although it holds the particles touching each other, the particles can move around and slide past each other. A bit like a jar of Maltesers, where the Maltesers can roll past each other, but they're still touching. In a liquid, the particles are moving all the time in all directions. It's hard to see when we draw a picture, but the particles in a liquid move around all the time in all directions. Add these important notes to your worksheet now about liquids. The particles are in a random arrangement, and the particles move in all directions. Finally, a gas. In a gas, the particles are in a random arrangement. The particles can be in any position. They are very far apart, and there are no forces pulling the particles back towards their neighbors. In a gas, the particles are moving around in all directions all the time. A bit like a swarm of bees flying around in all directions. Add that important information to your worksheet now. The particles are in a random arrangement, and the particles move in all directions. If you want to pause the worksheet now to finish the first page of your worksheet, do so and press play when you're ready. So let's think about some different materials. I'm going to think about solids. What I've done in school is I've used an electronic balance to measure the mass of different cubes of metal. I had different metals, but the cubes were all the same size. Different metals, but the same size cube. I put them on the balance. What do you think I noticed? Because they were the same size, did the cubes all have the same mass? Or did they have different masses? The results are on the next page of your worksheet. When we look at the results, we can see with 4 different metals, I got 4 different results. Even though the cubes were exactly the same size, they had different masses. We'll look at why that is, but before we start, we need to look at how a scientist prefers to write down a mass. When we put something on a balance, we get a mass in grams. A scientist always prefers to write a mass in kilograms. To change a mass in grams to a mass in kilograms, we need to divide it by 1000. You'll need your calculator for the next job. I'm going to change these masses in grams to masses in kilograms by dividing them by 1000. My calculator, I use 8.0 divided by 1000 equals, and I write the answer in, 0.008 kilograms. That is the mass of that cube of iron in kilograms. A kilogram is quite a large mass. It's about the amount of mass you would have in a 1 litre bottle of Coke. So you can see why a small cube has a small mass in kilograms. I want you to work out the masses of the other 3 blocks of metal. Pause the video now and type the answers onto your worksheet. We'll check the answers when you press play. Pause the video now. If you've done your sums, you should have got 0.0027 for the aluminium, 0.007 for the zinc, and 0.0192 for the gold. For each one that you got right, you can colour it in green or give yourself a tick on paper. If you got any of them wrong, go back and change them so you have the right answers now. So different metals, although their cubes were exactly the same size, had different masses. Why could this be? Well, we need to think about the particles. Although all the metals are solids, their particles can be packed closer or in different arrangements together to squeeze more particles into the cubes. It could be that each particle the metal is made of has a little bit more mass. The difference between these metals was their density. The density is the amount of mass a material has in 1 cubic meter. This is a fair way of comparing different materials. We think of cubes exactly the same size and think how many kilograms of mass they would have. The blue box is a very important definition. The density of a material is the mass in kilograms of 1 cubic meter of the material. Add that information to your exercise book now. You can press pause if you wish. To work out the density of different materials, we need to do a calculation. To work out how many kilograms are in 1 meter cubed of a material, we need to divide its mass in kilograms by its volume in meters cubed. We say that density equals mass divided by volume, or that density equals mass over volume. You'll need to remember this sum for your GCSE exams, along with other sums. Every time we teach you a sum, we'll teach you a triangle to help you remember it, and a mnemonic, a special silly phrase you can say to help you remember the letters in the triangle. For example, this triangle is made up of the sum mass, density, volume, MdV. You can see I've used an old-fashioned Greek letter for D for density. Mass, density, volume. We could say that density is mass divided by volume. We remember the triangle mass on the top, density, volume. We'll always teach you the triangles in physics with the first word on top of the formula triangle and the other words on the bottom of the formula triangle, MdV. To remember this, we remember the mnemonic, my dog vomits. MdV, my dog vomits. The mass in kilograms, the volume in meters cubed. This means that when we write something's density, we write it in kilograms per meter cubed. This is an important sum, and it's the first one you need to remember for your GCSE. My dog vomits, mass, density, volume. Make sure you have your calculator ready, and we'll practice using this formula triangle. Every calculation in your GCSE physics can be worth up to 4 marks. Let's have a look what we need to do to get 4 marks. This calculation is on your worksheet. The first calculation I've already done for you. You can follow along the calculation to see how we get to the answer. The question says, a block of iron has a volume of 2.5 meters cubed. Its mass is 19,500 kilograms. Calculate its density. Let's see the 4 things we need to do to work out the calculation and get the maximum marks. 1, we write down the formula or equation we are going to use. This question is asking us to calculate density. When you have found out what the question wants you to calculate, cover it up with your finger or thumb in the triangle and see what sum is left behind. If I cover up density in this triangle, it leaves me with mass over volume, mass divided by volume. So I write this calculation out. Density equals mass divided by volume. Next, my workings. I need to put the numbers from the question into this sum. Density equals mass divided by volume. The mass is 19,500. The volume is 2.5. So I write out my sum with the numbers in it. Density equals 19,500 divided by 2.5. This is the second tick. Now I use my calculator to work out the answer to the sum. 19,500 divided by 2.5. Type it into your calculator now. See if you get the same answer as me. 19,500 divided by 2.5 is 7,800. Great job. We've got the answer and the third tick. But we mustn't forget our fourth tick or our fourth mark. The units. Density is 7,800, but what do we measure density in? You can look on your worksheet, or perhaps you can remember. Density is measured in kilograms per meters cubed. Tick our fourth mark. So you can see how I write out my calculation to get the maximum marks. Let's do another one together, but this time you'll need to fill in the worksheet. You can see underneath the calculation that I've just shown you, there's space for another calculation. Let's see if you can follow along with me and write in this calculation. You can type it in if you're working on the worksheet, or you can write it on a worksheet if you've printed it. Let's see how we get our 4 marks again. It will always be the same 4 steps. It says a block of aluminium has a volume of 1.6 meters cubed. Its mass is 230 kilograms. Calculate its density. Let's do our 4 steps. First of all, let's write down the equation we're going to use. The question says calculate its density, so I cover up density in my formula triangle. I write out the sum that is left. Density equals mass divided by volume. Tick for 1 mark. You can add a tick or an X to the box on your worksheet. Now let's put the workings in. Mass divided by volume. The mass is 230. The volume is 1.6. So I can write these numbers into my calculation. 230 divided by 1.6. That's our second tick. Now I need to work out the answer. Use your calculator and work out 230 divided by 1.6. Have you got it? 230 divided by 1.6 is 143.75. That's our answer and our third tick. But don't forget your units. You can check on your worksheet, but hopefully you remember that density is measured in kilograms per meters cubed. Now it's your turn to try the calculations on the last piece of the worksheet. You can see that there are 1, 2, 3, 4 more of them for you to try using the formula triangle. But let's look at one more thing we need to remember. When the calculation asks us to work out a density, we cover up the density and we see density is mass over volume. But what if the question asks us to work out a mass? Well, I cover up the mass with my thumb and look at the sum it's left behind. Mass is density times volume. They are beside each other on the triangle. So I would multiply the density number by the volume. What if the question asked me to work out the volume of something? I cover up the volume and look what sum I'm left with. Volume equals mass over density. Mass divided by density. Remember, for each one, you must write out the sum you're doing, write out the workings, write the answer in, and give the units for your answer. Density is measured in kilograms per meters cubed. Mass is measured in kilograms. Volume is measured in meters cubed. Okay, it's your turn now to try the calculations on the last worksheet. 4 calculations where you'll either be working out a mass or a volume. Remember to do the correct sum from the triangle. You can pause the video now while you do those 4 calculations. When you unpause the video, we'll go through the answers and you can mark them to see if you've got the 4 marks. Pause the video now. Let's look at each one in turn. The density of gold is 19,320. What's the mass of the block of gold with a volume of 0.02 meters cubed? Let's have a look. Using our triangle, mass is density times volume. So we do our sum. Mass is density times volume. The density is 19,320. The volume is 0.02. So the mass is 386.4 kilograms. 1, 2, 3, 4 ticks. Let's look at our other calculation. What's the mass of a diamond with a volume of 0.002 meters cubed? The density of diamond is 3,500 kilograms per meter cubed. Mass is density times volume. Tick for 1 mark. The density is 3,500. The volume is 0.02. 1 mark. So the mass is 0.7. And then kilograms for your 4th tick. Next one. What volume is occupied by 3 kilograms of ethanol? Volume is mass divided by density. Volume equals mass divided by density. So we write out our sum. Volume equals mass divided by density. Tick. The volume, 3, divided by the density, 0.8, gives me a volume of 3.75. 1, 2, 3, and 4 meters cubed for the volume. Finally, what volume is occupied by 24,150 kilograms of copper? The density of the copper is 6,900 kilograms per meter cubed. Covering up the volume gives us volume equals mass divided by density. So let's look at our 4 marks. Volume equals mass divided by density. Tick for a mark. Our workings, 24,150 divided by 6,900. Tick for 1 mark. The answer is 3.5. Tick. And volume is in meters cubed. Tick. Those are our 4 marks. You need to make sure you fill in the whole worksheet and submit that when it's finished. Practice using your calculations and submit your completed worksheet. Good luck.